In preparation for your electrical engineering laboratories, you may need a piece of equipment which is called a protoboard or a breadboard. The breadboard or protoboard, as in prototype, allows you to connect circuits together. Ultimately, you'll be wanting a circuit that looks something like this at some point in time, where there's lots and lots of integrated circuits and resistors and capacitors and all kinds of other connections on there. But before you design a circuit like this, you'll need to develop a prototype to make sure that the circuit works correctly. And so we use the protoboard or prototype board. And as we use this device, we recognize that this has lots and lots of little holes in it. Those little holes are meant for connecting wires. So if I take wires and I attach them, by plugging them into one of those little holes, you can see that that wire now is available to put voltage or allow current to pass into that particular spot on the protoboard. And so if I want to connect wires together, I will take another wire and attach it in the same column, and now with those two wires are now connected together. And we can determine this because of the development of the board, that each of these 1, 2, 3, 4, 5 holes are all connected to each other internally. But these 5 holes are, although connected internally to each other, are not connected to the neighboring 5 holes or the neighboring 5 holes on the other side. And so you have 65 or so columns of 5 connected locations. These 5 are connected. They are not connected to anything else on the board. The next 5 are connected. They're not connected to anything else on the board. And so if I put something in column number 35, that is not connected to anything in column 36 or 37 or 34 or 32 or any other connection. The 2 wires that I've shown here are not connected to each other. I'll have to put both wires in the same column in order for those 2 to be connected. They don't have to be in adjacent holes, but they do have to be connected in the same column. Alright, so we have wires that can go in there. There's a couple other features that you notice, that there's a series of 5s across the top, which is just underneath this red line. Those are all connected to each other. We often call those rails, and they're designated with a plus sign and a minus sign. This is often used in order to power integrated circuit chips with a positive voltage and a negative voltage. So all of these are all connected to each other. The next row is not connected to the first row. The plus row is not connected to the minus row, but all the points along the blue line are connected to each other as well. I've put an integrated circuit into this protoboard to show you that the sizing of this integrated circuit is designed for this space across the center. And so therefore the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 pins on this particular integrated circuit. All these pins fit nicely into the holes on either side, and now I can power that thing up. And so therefore when you look at an integrated circuit, you find that there's a little notch in one end. That little notch determines the position of pin number 1, which is directly to the left of it. And so if I want to put some voltage on pin number 1, I will stick my wire into one of the 5 holes that are connected to pin number 1, and then I can apply a voltage to pin 1. I want to apply another voltage to pin number 8. I will stick my wire in the set of holes that are connected to pin number 8. And so therefore I can put power or signals or outputs to and from this particular integrated circuit by means of connecting the prototype board. So I can wire or connect or put together any number of circuits using this prototype board and using the connection features of each of the holes and the location and layout of the particular holes.